Hello again, Math 10Cs. In today's lesson, we're going to talk about what the x and y intercepts of a graph are, and I'm going to show you how to calculate the x and y intercepts algebraically, although we can determine the x and y intercepts if we have a graph and simply know what information on the graph to look for. So we'll also look at that. Let's start off by completing this section of review, which kind of deals with the previous few lessons you've been looking at in this unit. So a relation is a connection between two quantities, and a relation can be represented graphically by a set of ordered pairs. So I'll grab my pen. Then ordered pairs is written in the form x comma y. The first component of a set of ordered pairs is the x-coordinate, also known as the input. And values of the input are referred to either the independent or manipulated variable. We'll use the word independent here. And the second component of a set of ordered pairs is the y component, also known as the output. Values of the output are values of the dependent variable, dependent or responding. So we have three graphs, graph 1, graph 2, graph 3. They all have different types of shapes to them. And what I want to do is I want to look at these graphs and I want to identify, list the coordinate of the points where each graph crosses the x-axis. Okay, so the x-axis is the horizontal axis. So what I want to do is just simply identify the coordinates of the point that crosses the x-axis. So in the graph on the left-hand side, my x-coordinate that crosses my ordered pair that crosses the x-axis will be located right here. And if I write down the coordinates of that point, it would be -3, 0. For the second graph, I actually have two spots where the graph hits the x-axis. We've got one spot right here. And we got another spot at this location. So this left-hand side, the graph crosses the x-axis at -2, 0. And on the right-hand side, the graph crosses the x-axis at 2, 0. Oh, here, let's erase that so we can actually make it legible. The computer's froze for a second. Okay, 2, 0. There we go. Now, graph 3, it also has two spots where it crosses the x-axis. There's one point that's located here. And there's another point that's located over there on the right side. So the point where it crosses the x-axis on the left side would have a coordinate of, that should be -4, 0. And on the right side of the graph, it crosses it at 4, 0. B asks, what do all points in A have in common? Well, if you look at them all, they all have the exact same y coordinate. So all the y coordinates are equal to 0. Okay, then C says list all the coordinates of the points where the graph crosses the y-axis. Okay, I'll use a different color for this now. So let's go back up to our first graph. So the graph crosses the y-axis at this point. And the coordinates of that point would be 0, 5. If we go up to the second graph, there's only one spot where this graph crosses the y-axis, which would be like kind of close to the top of the graph, so at this position. And that looks like 0, 6. And then if we go up to the this graph, we actually have two spots where we cross the y-axis, the very top of this circle and at the very bottom of the circle. At the top of the circle, that point where it crosses would be 0, 4. And the spot where it crosses the y-axis at the bottom of the circle would be -4, 0, or 0, -4. So what do all these have in value? Or what do these points all have in common? Every x coordinate is 0. So the x coordinates are 0. All of these spots where the graph crosses the y-axis and you have an x coordinate that's 0, those are referred to as the y-intercepts. So what a y-intercept on a graph is it's just the spot where the graph intersects with the y-axis. So on graph number 1, your y-intercept would be y = 5. On graph number 2, your y-intercept would be y = 6. On graph 3, you have two y-intercepts, which would be y = +4 and y = -4. Now, all these spots here, where you have the graph cross the x-axis, we refer to these as x-intercepts. So x-intercepts are where my graph would cross the x-axis, and when they cross the x-axis, the y-coordinate of your point would just be equal to 0. So in the first graph, the x-intercept is where the graph crosses the x-axis, so that would be x = -3. On graph number 2, you have two x-intercepts. It crosses at x = -2 and x equals, oh, that's +3 there. I just realized that. We need to, did I write that down wrong? Yeah, this should actually be +3 here. So let's fix that. Yeah, this should be +3. Yeah, -2 and +3. So your x-intercepts here would be x = -2 and x is equal to +3. And then on this graph, you'd have two x-intercepts, one at x = -4 and one at x = +4. So this page starts off by giving some definitions of what an x and y intercept is. So the x-intercept of a graph is the x-coordinate of the ordered pair where the graph intersects the x-axis. Okay, x-intercept just means intersection on the x-axis. An x-intercept that occurs at a point on the graph where the y-coordinate is 0. Okay, and we showed that. All of my x-coordinates had y-coordinates that were 0. And the x-intercept can be given either as a value or it can be given as an ordered pair. So let me give you an example of this. If you go back up to our first graph, there's two ways we could write down the x-intercept. We could write down the x-intercept as just being x equals -3. So we could say x equals -3. Or you could write it down as an ordered pair. So as an ordered pair, the point where the graph crosses the x-axis would be -3, 0. So there's two ways to write it. Just as a value, the x-intercept is -3, or as the actual point where it crosses, where you can see the y-coordinate is 0. The y-intercept of a graph is the y-coordinate of the ordered pair where the graph intersects the y-axis. And a y-intercept occurs at a point on the graph where the x-coordinate is 0. And again, we showed that. All of my y-intercepts had x-coordinates that were 0. And the y-intercept can be given as a value or an ordered pair. So if we go back to our first graph again. So my first graph has a y-intercept of y equals 5. So there's two ways we could write that. We could either write it as y is equal to 5 for my y-intercept, or you could write it down as an ordered pair. So as an ordered pair, it would be 0, 5. X-intercepts have y-coordinates of 0. Y-intercepts have x-coordinates of 0. What we want to do, though, is we want to take the equation of a graph and we actually want to algebraically determine the x-intercept or the y-intercept. So if we have an equation and we want to figure out the x-intercept, what we do to the equation is we set y equals 0, and then we just simply solve for x. If we want to figure out the y-intercept, we take the equation and we replace x with 0 and then solve for y. And we'll do this right now. Okay, so it says the equation of the graph on the previous page for graph 1 is 3y is equal to 5x plus 15. Algebraically determine the values of the x-intercept and the y-intercept of that graph. Okay, so here's what you need to know. When you're trying to figure out the x-intercept of a graph, the x-intercept of a graph will always be where y is equal to 0. The reason being is if y is equal to 0, then your point has no height relative to the origin. So it's just simply along the x-axis. So let's write our equation down. So we'd have 3y is equal to 5x plus 15. Now, to figure out what the x-intercept is algebraically, what I do is I take this equation and I replace y with 0. So what I'm going to do is on this side where it says 3y, I'm going to put an arrow through it. I'm going to write down that's equal to 0. Okay? Because the value of if the value of y is equal to 0, then 3 times y would also be 0. So this would then leave me with 0 would be equal to 5x plus 15. To get the x-intercept, I just need to solve this equation for x now. So the way I would do that is I'd start off by subtracting both sides by 15 because I want to isolate x. So subtract 15, subtract 15. And that would leave me with negative 15 would be equal to 5x. And then you get the x by itself. You're just going to divide both sides of the equation by 5. So divide 5, divide 5. This 5 and this 5 cancel off. And then that would leave you with negative 15 divided by 5 would be negative 3. That's supposed to be a 3. But it's better to write the variable first. We'd write down x is equal to negative 3. Or if you wanted to write it down as an ordered pair, you could write the x-intercept as being negative 3, 0. So either or is fine in terms of how you write down the x-intercept. I think that's the value we had up here. Yeah, we said the x-intercept is x equals negative 3. Now, the y-intercept is where all x coordinates are equal to 0. If your x coordinates equal to 0, it means that you're just along the y-axis. So let's start off with our equation again. So we have 3y is equal to 5x plus 15. And this time around, I'm going to replace x with 0. So this 5x term is actually going to become 0, because if you replace x with 0, then 5 times 0 would just be 0. Therefore, I would then have 3y. Oops. Three y would be equal to 15. And then to solve for the y-intercept, all you have to do is divide both sides of the equation by 3. Divide by 3. The 3's on the left-hand side would cancel. And then this would then leave you with your y-intercept, which would be 15 divided by 3 is 5. Or we could write it down as an ordered pair. So as an ordered pair, the y-intercept would be 0, 5. And if we check up at the top here, that is the y-intercept we identified off the graph. Second example, we're looking at the equation for graph number 3. So that's the one where we have the circle. So the equation is x squared plus y squared is equal to 16. And same thing, we're going to calculate the x and y intercepts of the graph, and we're going to do it algebraically. So the x-intercept is where your all y coordinates must be equal to 0. So we're going to start off with the equation that's given, which is x squared plus y squared is equal to 16. And then we're going to simplify this equation by getting rid of the y term. If y is equal to 0, then y squared would be equal to 0. So I can get rid of that whole part. Then I'd be left with x squared is equal to 16. To solve for x, to undo that square, I would then take the square root of both sides. And if you take the square root of both sides, it turns out the square root of 16 can actually be either positive or negative 4. Because positive 4 multiplied by positive 4 would be positive 16. But also, if you have negative 4 times negative 4, negative times a negative is a positive, so that would be positive 16. In our unit of study, when we were dealing with radicals, we only looked at the principal square roots. The principal square root meant just take the positive one. But in this situation here, we actually need to look at both of them because we have two x-intercepts. We have one at positive 4 and we have one at negative 4. You could also write this down as an ordered pair where you have two x-intercepts. So you could write down negative 4, 0 and 4, 0. And if we go back to the previous slide, we can confirm that. So on the previous page, yeah, we can see we have our x-intercepts. So that's the blue ones here at negative 4 and positive 4. So algebraically, we confirmed it. Now, to get the y-intercepts, all y-intercepts would have an x coordinate value that's equal to 0. So we start off by writing down our equation, which is x squared plus y squared is equal to 16. And this time around, we're going to replace x with 0. So if x is 0, then that means x squared is 0. So I can get rid of that whole thing. And then this will just leave me with y squared is equal to 16. And then take the square root of both sides to solve for y. Square root of that side. And then what I would have is same thing. So the square root of 16, we can actually look at both roots. So we have the positive one and the negative one. So you have positive plus or minus -4, or we can write it down as ordered pairs. We can write down 0, comma, -4, and 0, comma, +4. And if we go back to that previous page, we can see that. So the y-intercepts would be these red stars here. So we have y-intercepts at +4 and at -4. So that's how you figure out the x and y-intercepts algebraically. For whether you do x or y-intercepts, you write down the equation that's being used to describe the graph you see. And if it's an x-intercept, you plug in y equals 0 and solve for x. If it's the y-intercept you want, you plug in x equals 0 and then solve for the value of y. Let's go to the last page now. So it says Lisa purchases a new car for $20,000. The value of the car can be represented by the formula V is equal to 20,000 minus 1250 times T, where V is the value of the car in dollars and T is the age of the car in years. So it says A, complete the table of values and plot the ordered pairs on the grid. So what I need to do is to determine what the output values are, I need to plug a bunch of these input values into the equation. So in the place of time, I'm going to plug in t equals 0 and solve for v. And I'll plug in t equals 2 and solve for v. Plug in t equals 4 and solve for v. Plug in t equals 6 and solve for v. Okay, let's find some space to do this. So I'm going to have to just do it at the top of the page here. Okay, so if t is equal to 0, and I want to get the value of v, I'm just going to write the equation down and substitute in t equals 0. So this would then be v would be equal to 20,000. And I'm going to subtract 1250. And again, anytime you substitute in a value, you put it in brackets. So this would be 20,000 minus 1250 times 0. Well, 1250 times 0 is just 0. So this is going to give you a value of v, which would be equal to 20,000. Okay, so I got 20,000. So my ordered pair would be 0, comma, 20,000. Okay, let's do it for t equals 2. So if t is equal to 2, this would be v is equal to 20,000. Subtract 1250, multiply by 2. 1250 times 2 would be 2,500, and then 20,000 minus 2,500 would be 1,000 or 17,500. You can also plug that into your calculator if you want. So you got 1,7,5,0,0. Okay, so then we got 2, and then 1,7,5,0,0. Let's close that off. And then we have t is equal to 4. And then this would be v is equal to 20,000. Subtract 1,250. Multiply by, this time we're going to plug in 4. And then we'd have 1250 times 4 would be 5,000. So this would just be 20,000 minus 5,000, which would be 15,000. So we put that in the table, 15,000. My point would be 4, and then 15,000. What I always recommend doing is after you've identified 3 points in the table, I would then check to see if you have if there's a pattern that you can use to figure out like what the remaining points are. So I think here we actually do have a pattern we can observe. So if you look here, for every increase in 2, it looks like the output value is decreasing by a constant number, which is 2,500. So when t is equal to 6, then I just remove another 2,500, and that would give me 12,500. So that would be 6, and then it would be 12,500. Okay. Now it wants me to plot these points on the graph. So the y-axis is v, which is the value of the car, and then the x-axis is going to be t, the time. Okay, so let's plot the first point. So the first point would be 0, 20,000. So starting at the x-axis at 0, I just go straight up to 20,000, which would be, let's give it a moment. Evidently the program cannot handle me scrolling up and down quickly. Okay, there we go. The technology is too advanced. Okay, so 0, 20,000 is up here. Then we have 2, and then 1,700 or 17,500. So 2 would be located here. So I go 2 to the right, and then 17,500 up. So that's going to be located halfway in between these two. So it's going to be here. Then we have 4 and 15,000. So I'd go right by 4 and then up to 15,000. So then this point's going to be located right here. And then the last point is 6, 12,500. So we'd go 6 to the right and then 12,500 up, which would be at this point. Now it says connect these points with a line. Okay. So let me pull a line up here. I'll do it in red. Okay. So let's start off with this point. I'm gonna have to do 2 lines just because I can't quite get this to fit on the screen here. Okay, so that's the first one. And then I'm just gonna draw another line where I'm just gonna extend it further downward. So I'll do another one that goes from all the way down. So maybe it looks like about that. Okay, you should be able to do this just with one single line. My screen is I can't get the graph to fit on just one screen, so I have to do two line segments to represent the one line. Okay, now B says, what does the ordered pair 0, 20,000 represent? Well, 0 means the value of the car when time is equal to 0. The thing with the purchase of a car, you've maybe like heard people like say this before, but essentially is once you buy a car and as soon as you drive it like off like the dealership lot, assuming you bought it from like a dealership, the value of the car goes down immediately. Like a car is for the most part, most cars are depreciating assets. So in terms of like what does the ordered pair 0, 20,000 represent? Well, that would be the value of the car at time equals 0, which is just the original value of the car. C says use the graph to estimate the t-intercept, and what does the t-intercept represent? Okay, the t-intercept is where the graph hits the t-axis. So if I look here, approximately where does it hit the t-axis at? That looks about t equals 16. Okay, so we could write down t is equal to 16 if I want to write it as a single value, or if you want to write it as the t-intercept as an ordered pair, you could write down 16, comma 0. Now, what does this represent? Well, this means after, so time is in years, after 16 years, it tells you what the value of the car is. So what's the value of the car after 16 years? Nothing, okay? So it's basically the time required for the car to have no value. I don't know how realistic that is. Like, yeah, cars for sure depreciating asset. But I mean, even if the car doesn't work at all, like you could probably at least get some money for like the parts. But anyways, let's not overcomplicate it here. Okay, D, it says use the graph to estimate the value of the car after 3 years, 10 years, and 14 years. Okay, so what I would do is I'm going to go to the t-axis, and go to 3. And then basically just go straight up. So we go all the way up, which is taking forever to get up here because this graph is huge. Okay, so just keep going up. So what I'm doing is I'm interpolating here. Now I think like this, I think if I draw on this line like really accurately, I think that like if you start at t is equal to 3, it should hit the graph just a little bit above here. Okay, so maybe at like this point. Okay, about right here. So you go across. Okay, halfway between 16,000 and 17,000 would be, so this would be 16,500. But we're halfway between 16,500 and 16,000. So that would actually be the value of the car would be 16,250. After 10 years, same thing. Let's go up. Okay, thankfully we don't have to go as far up here. So at 10, we just go up to the graph. Now we're extrapolating because we're outside of our data point range. Okay, and it goes across here. Okay, so this would be 7,500. So it looks like we're between 7,000 and 7,500. Therefore, the value of the car at 10 years would be, looks like 7,250. And how about 14 years? So 14 would be right here. So if we go up to the graph, it looks like it pretty much hits that grid line intersection here. So let's go across now. And I'd say it hits it at about 2,500. E says use the formula to verify the answer we got in D part 2. Okay, so our equation, if we go all the way back up to the top here, is V is equal to 20,000 minus 1250t. So let's write that equation down again. V is equal to 20,000 minus 1250 times t. And what I'm going to do is I'm going to verify that we estimated off the graph correctly by taking the value of time, which is 10, And I'm just going to replace it in the equation. I'm going to substitute it in for the value of t and see what the equation gives me for the value of the car. So that would be V is equal to 20,000 minus 1250 times 10. Again, when you sub stuff in, put it in brackets. And this would be, well, 1250 times 10 would just be 12,500. And then 20,000 minus 12,500 would be 7,500. Okay, so my numbers were not quite the same. 7250, 7,500. So the answer in E is correct, okay? D was an estimation. It required me to use my line of best fit, which, I mean, if I actually could have used a ruler and drawn this by hand, I really feel like I could have made like a very good line of best fit. So I think my line of best fit is just off a little bit. So that's why there's that small discrepancy. There's just error in the line of best fit that I drew with the smart technology program here. F says use the graph to estimate when the car will be worth $5,000 and half of the purchase price. Okay, so we're just going in the opposite direction this time around. So this time what we're going to do is we're going to start on the y-axis or the v-axis, go over to the graph, and then figure out what that time value is. So if we go to 5,000 and I go across, and again, there might be a little bit of discrepancy between like what I get and you get just based on the line. Now, it does look like it actually hits this grid line intersection here. So then if we go all the way down, that looks like 12. So I'd have my time would be equal to 12 years. Okay, when will the car only have half of its purchase price? Well, remember, the original purchase price is 20,000. So half of the purchase price would be V is equal to 20,000 divided by 2 would be 10,000. Okay, so let's go up to the graph at 10,000 and then go across. And it looks like the line has a grid line, it hits at a grid line intersection. So then we just drop down here. And it's looking like it's hitting at 8. I mean, that makes sense. I mean, if it takes 16 years for the car to have no value, then the time for it to have half that value would just be 16 cut in half, which is 8 years. So T would be 8 years. Now it wants me to verify this with the formula. Okay, so let's take our formula, which is V is equal to 20,000 subtract 1250 times T. And what I want to do is I want to verify that when V is 10,000, the value of T is going to be equal to 8. So I'm going to plug V equals 10,000 into the equation. So if I do that, then the equation would then look like 10,000 would be equal to 20,000 minus 1250 multiplied by T. Now, this is a bit tougher to find because I actually have to isolate for T now. So the way to isolate for T is get rid of that 20,000 first. So I'm going to subtract 20,000 from both sides. After you subtract 20,000 from both sides, you then have negative 10,000 on the left-hand side. And you'd have negative 1,250 times T on the right-hand side. And then now to get T by itself, just divide both sides of the equation by negative 1250. Divide negative 1250. And then when you do this, we actually do get the same thing we got than we estimated from the graph. So I guess my line of best fit was good enough for this one. Negative 10,000 divided by negative 1,250 would be 8. So this would also be 8 years. And then H, which is the final part of this problem, says complete the following statement that describes the relationship. So the original value of the car is $20,000. It depreciates in value by how much per year? Okay, well, let's go up and look at this. So if we look at this graph, look at the table, we can identify how much it depreciates by in a year. So over 2 years, it depreciates by 20,000 minus 17,500 would be 2,500. Okay, so that's how much it drops after 2 years. So how much would it drop after 1 year? Just cut that number in half. So if it depreciates by 2,500 over 2 years, then the amount it would appreciate over 1 year would be 2,500 divided by 2. So that would be $1,250. That's actually why you're seeing this number here, the 1,250 in the equation. It's showing how much it's depreciating per year. In a later unit, we're going to look at how we can write the equation of straight lines, and then that'll make more physical sense why that number is there when we actually talk about the slope of a graph. Okay, so it depreciates in value by 1,250 per year, and it has no value after 16 years. All right, so that is it for this lesson. And you can complete, starting on page 416, do numbers 1 through 5, and do all parts for every question. You're going to find 1, 2, and 3 get kind of tedious because it's going to be you algebraically determining the X and Y intercept, but I really want to drill on the point of how to figure out these X and Y intercepts, because this is going to be something we're going to need to be able to use quite a bit moving forward when we start to look at determining the equation of a straight line. And I'll talk to you in the next lesson.